Okay, so we're going to talk about lasers. And laser is an acronym, surprisingly enough, for light emitted by stimulated emission radiation. And I'm going to tell you about the basic of all basics in lasers. So what are lasers? They are monochromatic, which means that they're only one wavelength, only one wavelength. They are also coherent, which means they're all in phase. The wavelengths are all in phase. So they're not, just going about wherever. They are parallel to each other. And they're also collimated, which means that they are highly focused into this one point. They don't disperse as much as normal light. Okay, so we're going to go behind what lasers are, like the theory behind lasers. And it is basically electromagnetic radiation that is emitted when a charged electron gives up its energy. Han will mention later on when an electron drops from a higher energy, the Bohr atom diagram, here you go. When an electron drops to a lower energy, it will emit an energy. So the color of light is determined by its wavelength or frequency. Now, in many science courses, we learn that the shorter wavelengths are usually UV radiation, while the longer wavelength is infrared radiation. Now, in quantum mechanics, photons are the smallest particle of light energy. Now, we have this equation for the energy, which is E, energy, equal Planck's constant nu. Nu is the frequency of the photon. To find the wavelength, we have lambda wavelength equals c, speed of light, which is 3 times 10 to the 8 meters per second over nu, which, as we found out before, is the frequency. Now, the difference in level which the excited electron drops determine the wavelength. So all we need is to plug and chug for the desired wavelength.
Hi guys, I'm going to talk about what is laser made of. And to have an idea of what is laser made of, well, let's briefly go into the concept of how does laser work. Okay. So in laser, we have a collection of atoms. Each atoms have electrons around. So what do we do in a laser? Is we use electronic energy. We supply electron energy to those atoms to excite those atoms. And by exciting those atoms, they go into a higher energy state. It's called electronic excitation. And when they drop down to the ground state, it's called electronic ionization. When they jump, at the process of jumping down, they emit a photon, which is light. And imagine all these atoms emitting photons. And due to properties of both emitted photons, they tend to be coherent. And quantum mechanical properties is they amplify too. My plan will go into detail about the concept and quantum theories behind it. And we have a bunch of photons. This system is called the gain medium, which is part of the laser. And instead of letting the photon escape, we put some mirrors around it, called high reflectors. They just basically mirrors and they reflect photons back and forth. And that's also part of laser. And to have a beam of laser light coming out, you just open up the reflector a bit. That's streams of coherent photons coming out. This is called output coupler. And you have a coherent beam of laser, which is nice. They don't scatter as much as ordinary lights. So, in short, in a standard laser, light amplification, stimulated emission radiation system, you should have a gain medium where photons come from by electronic excitation or other type of excitation. Optical cavity, which is the mirror system, and also a output coupler. So that's basically the three main components of a standard laser. Okay.
So why are lasers important? We've learned the theory behind them, we learned how they're made, but why are they important? Why are they so important? I mean, we could use a light bulb, right? But the light bulb is not useful for us because it emits all types of different wavelengths and density is almost uniform. So we can't use this. But with lasers, we can choose, someone already mentioned they're more correct, so they're one wavelength. So we can choose different wavelengths depending on what we want for experiment or if we want to do an application. Sumi will go over how lasers are used.
Lasers have many types of applications due to the fact that they have the property of being highly directional and focused. Some of the applications of laser include lasers in communication, heat treatment, medicine, industry, defense, research, and etc.